A capacitor is a device that stores electrical energy, in the form of electric charges on its plates, similar to a battery. Capacitors and batteries are both energy storage devices, but they store and release energy in different ways. Batteries store electrical energy through chemical reactions, while capacitors store electrical energy in an electric field. This means that capacitors can store and release their energy much faster than batteries, but they cannot store as much energy as a battery does. Capacitors are generally faster in charging and discharging, making them suitable for applications that require quick bursts of energy, such as flash of a camera, starting a motor, and smoothing out variation in the output of a power supply, such as those found in mobile chargers. A water tank is a good analogy for understanding how a capacitor works. Imagine a water pipe with a valve on one side. When the valve is open, water flows out at a constant rate. However, if the water pressure in the pipe fluctuates, the water flow will also fluctuate, and the steady flow will be interrupted. To maintain a steady flow of water, a water tank is necessary. During periods of high pressure, the excess water will be stored in the tank. During periods of low pressure, the stored water in the tank will continue to flow out and maintain a steady flow of water. Similarly, in an electrical circuit, a capacitor works in a similar way. A capacitor acts as a temporary reservoir of electrical charge. If we switch a light bulb on and off rapidly without a capacitor, the light will flash. If we connect a capacitor into the circuit, the bulb will remain illuminated during the interruptions. Because the capacitor stores and releases the energy during interruptions. If we connect the bulb to a fluctuating voltage source, such as a power supply, with uneven output, or an electric generator that is not running smoothly, the light will flicker. To smooth out these fluctuations, we can use a capacitor. The capacitor charges and discharges in response to the voltage changes. During periods of high voltage, the source powers the bulb, and the capacitor rapidly charges, absorbing excess energy and preventing the voltage from rising too high. During periods of low voltage, the capacitor discharges, releasing stored energy to maintain a constant level of the output voltage across the bulb, ensuring a steady flow of current and preventing the light from flickering. Maintaining a constant voltage level across a load, despite variations in the input voltage, is called voltage regulation. Capacitors are widely used in power supplies for voltage regulation. A capacitor consists of two conductive plates, separated by an insulating material, known as a dielectric. When connected to a voltage source, positive charges accumulate on one plate, while negative charges accumulate on the other. This accumulation of charges represents the stored electrical energy in a capacitor. Charges create an electric field between the plates, allowing the capacitor to store energy in this field. The ability of a capacitor to store electric charge is called its capacitance. It is measured in farad. 1 farad is the capacitance of a capacitor that stores 1 coulomb of charge when the voltage across its terminals is 1 volt. To enhance the capacitance of a capacitor, without changing its physical dimensions, we place a dielectric material between the plates. Positive and negative charges within the atoms of the dielectric material separate, due to the influence of the external electric field between the plates. This separation of charges is called polarization. A pair of opposite charges separated by some distance is called a dipole. Polarization produces layers of opposite charges on the surface of the dielectric material, that attract more charge onto the plates of the capacitor. This increases the capacitance of the capacitor. The ease with which a dielectric material can be polarized is called permittivity, or dielectric constant of the material. The higher the dielectric constant of the material, the more easily it can be polarized and the greater its effect on the capacitance of the capacitor, allowing the capacitor to store more electrical energy. Capacitors are used in a variety of applications, including energy storage, signal filtering, and time delay circuits.